There's traffic in the sky and it doesn't seem to be getting much better.
Hello, today's exercise is the 2015 Ordinary Level question C1 on the DCG paper, which is the Geological Geometry question. Okay, so just to get started here with the question, the accompanying map located on the back page of section A shows ground contours at 5 meter vertical intervals. Again, as always, I'll underline the 5 meter intervals just to clarify that for the question. Part A. On the drawing supplied, draw a vertical section or profile on the line AB. Part B. C, D and E are outcrop points on the top surface of a stratum of ore. Determine the strike and dip of the stratum. Part C. The stratum has a thickness of 10 meters in your auxiliary, which shows the dip. Draw the bottom surface of the stratum. Okay, so one thing to note in this particular question, there is no actual road or anything going in place. Okay, part A, B and C, as you see, with no road on the question. So I'm just going to start off with the first part, which is part A, to draw a vertical section on the line AB. Okay, so here we have our vertical section, or line AB, in which we want to draw the vertical section in order to show the profile of the land up here. Okay. First thing again I'm going to note is just the range and altitudes, alright, so we're going up as far as an altitude here of 65 meters where it's crossing the line. Okay, we also have 70 there, and the contour lines going down as far as 40, down as far as 35. Okay, so as we're working at 5 meter intervals, I'm just going to mark in our intervals for the heights here in this view. Okay, so I'm just going to mark them in right up from 30, starting at the bottom, 30, 35, up as far as 70. Okay, the next thing I'm going to do, just on the left hand side for clarity, I'm just going to mark in the heights of our contour. So this first one here I'm going to mark as 35, and so on up as far as the top in 5 meter intervals. Now we have our heights in, I'm going to project where the line AB, okay, where this line intersects with all these different contours as you see here. Okay, so I'm going to project those points up onto the corresponding height in this view here. Sorry, made a mistake here, so this should be 55 down here. Okay, so now that I have those points, I'm going to join the points in order to plot the shape of the profile. Okay. So once you join those points from one end to the other, this will give you the profile, as you see here, of what the surface from the vertical section will appear as. So this here is known as your profile. Okay, the next part of the question is part B. So C, D and E are outcrop points on the top surface of a stratum of ore. Determine the strike and dip of the stratum. Okay, so we have here, as you say, point C, D and E in plan. Basically we're going to join those to form the triangle, which is a part of the stratum, and we're going to project them up onto the corresponding heights here in the elevation in order to determine our strike. Okay, so how do we know the heights and elevation? We follow them along here on the contour of each point. So D is on 50, E is on the contour line of 35, and C is on point 70. Okay, so I'm going to project those points up as I said. I'm just going to bring them up here with the blue pen as well to the corresponding heights. Okay, so we have our point E, which is on the contour of 35, so I'm going to project that up. Do it in dashed line at point E. D is on contour line, which is 50 mil altitude, which is here. And C is on the altitude contour 70. Okay, so now that we have located the outcrop points in elevation, we need to determine the strike. To determine the strike, I'm going to bring a horizontal line, which is a level line in elevation, from point D until it hits the line CE. I'm going to drop this point down onto the line CE in plan, which is here, and I'm going to join that again back to D. This then is your line, which is known as the strike. I'm just going to write that there, the strike. Okay, for the final part of this question, of part B, sorry, we're asked to determine the dip of the stratum. Okay, so what I'm going to do, I'm going to project our lines out parallel to the strike. So if you think of an auxiliary elevation, it's going out parallel to the strike with points D, C and D. So point D is already done, which is on the line of the strike. Bring out point E and point C. Okay, and again, I'm just going to, as we do with the auxiliary elevations, bring out an XY line here. Give us a point of reference on the horizontal plane. That's your XY. So it's back to basics again really after this. We're going to measure each point, so we're coming back 2 views. We're going to come back 1, 2 and measure our elevations. So point E is up 5 meters. Point D is up, as you see here, at 50. So measure it up with your set square or compass just to make sure they're corresponding to all views. And point C. Okay, so if you join those 3 points, you'll notice that they appear as a straight line, which is correct. Alright, so I'm just going to mark them in. You have C, D, and E. Okay, back to the point of the question again. We need to determine the dip of this stratum. Okay, so the dip is basically the angle that the stratum makes to the horizontal plane, which is your XY line. So it is this angle here. You could measure it and write in the measurements, or you could just put in the symbol for the dip as seen here. Okay, the last part again of the question, which is part C. The stratum has a thickness of 10 meters. In your auxiliary view, which shows the dip, draw the bottom surface of the stratum. Okay, so this is quite simple. It's basically you're drawing the bottom surface. We know this is the top surface of the stratum if you're looking from the XY line. So we're going to draw the bottom one, which is going to be this side towards the XY line. Okay, and we're given really the only piece of information that we need there is that the thickness of the stratum is 10 meters. Okay, so I'm just going to come off perpendicular to the top surface of the stratum. I'm going to slide across my set square, mark the equivalent of 10 meters, and I'm just going to draw in the bottom surface. Okay, and again, if you want, you could just mark it in there, 10 meters. Again, of course, that measurement is perpendicular to the top surface. All in all, that's the question complete. Quite a let's say an easier approach to the question. We've no roads, so it's just a matter of finding, first of all, just a recap or profile of the cut vertical section. Secondly, we were asked to determine the dip and strike of our stratum. So we have our strike here, we have our dip here, and then finally we were asked to get the bottom surface of the stratum, which is 10 meters thick. Okay, so please, if you liked this video and if you found it beneficial to you, please give it a thumbs up. Thank you.